Okay, page 2. Here are two linear equations for us to solve. We'll go ahead and make sure that these cancel out. Multiplying this top one by a -4. Negative 4x minus 8y is equal to -8. Oh heavens, a positive 4 would have been good. You can keep everything positive. Negative 4x plus 6y is equal to -15. That's just this equation right there. My x's cancel out, and I get 14y's are equal to -7. Divide by 14, divide by 14, and y is equal to -1/2. When I go to substitute in for x plus 2 times my value for y is equal to 2. So I'm going to go ahead and put that -1/2 right in there. So x minus 1 is equal to 2. Add 1 to each side. X is equal to 3. Therefore, over 3 down 1/2 is my solution. Alright, I take a look at this next one. And I don't have any easy zero pairs. If I multiply this one by 3 and this one by -2, I'll end up with a zero pair for my x's. 6x minus 21y is equal to -30. -6x minus 4y is equal to -20. Here's a zero pair. -25y is equal to -50. Divide by -25, divide by -25, y is equal to +2. 3x plus 2 times my value for y is equal to 10. Take this 2 and put it in there. 3x plus 4 is equal to 10. 3x is equal to 6. Divide by 3. Divide by 3. X is equal to 2. Therefore, my solution to the linear system is 2, 2. All right, next up, identify the coordinates of the following system of equations. Choose all that apply. Because y here is solved for, I can go ahead and substitute that in. So I can have x squared plus my value for y is equal to 4x minus 7. So this value for y, -2x plus 2, I'm going to substitute in. X squared minus 2x plus 2 is equal to 4x minus 7. It's a quadratic, so I want everything set equal to 0. I'm going to subtract 4x and add 7 to each side. Subtract 4x and add 7 to each side. X squared minus 6x plus 9 is equal to 0. We won't worry about this. When I go to factor, x minus 3, x minus 3, x is equal to +3. That's my only x coordinate for that system of equations. For number 10, x plus y equals plus 10 equals 0. X squared plus y minus 2 is equal to 0. I'm going to go ahead and multiply this one by a negative. And I'm going to have my x's cancel out. Oops, my y's cancel out, not my x's. So that gives me x squared minus x, because this x was not a quadratic. My y's cancel out. Minus 12 is equal to 0. When I go to factor, x squared factors into x and x. Minus 4 plus 3. X is equal to 4 and negative 3. What are the x values for the solutions? Positive 4 and negative 3. Last one. What is the value of the y coordinate of the solution to this systems of equations? My y coordinate is going to be when x cancels out. I can't cancel x out first though because I have a quadratic. So I'm going to have to solve for x. This y is equal to x plus 1. I'm going to set each of these equal to each other. X plus 1 is in for y. X squared minus 3. X plus 5. It's a quadratic, so I want everything equal to 0. So I'm going to subtract my x. X squared minus 4x. I'm going to subtract my 1 plus 4 is equal to 0. 0 is equal to x minus 2 times x minus 2. Therefore, x has a value of 2. When I substitute in for y is equal to x plus 1. This 2 goes in. Y is equal to 3. My value of the y coordinate of the solution to this systems is 3. Now again, remember, anytime you want to, you can go ahead and graph. And if you're unsure, you're like, wait, that was a quadratic. Maybe I should check and see if I got it right. X squared minus 3x plus 5 and x plus 1. Zoom 6 fixes whatever previous you had on your graph, and this looks like it only touches it once. If you want to see closer, you could try doing choice 1, Z-box. Z-box allows you to draw a square or a box around whatever coordinates you had to blow up the picture, so you can see if it is actually just one graph. Let's try that again. Z-box, and I'm going to go ahead and hit enter and draw my box up. I draw my box over. Last time I hit graph. This time I'm just going to hit enter, and that blows up that box, and I can see, yep, it hits exactly one time. So there's my one solution. If I want to look at it through a table of values, when y is equal to 3, or when x is equal to 2, y is equal to 3 for both of these equations. So I know I did it right. Good job, everybody.